Hello, everyone. My name is Xingyan Tan, and I'm the product leader for Analytical Instruments, Emerson Asia Pacific. Today, I'll be sharing with you about Emerson Hydrogen Flame Detector. Unlike gas detection and conventional fire detection, with smoke and heat, all of which have a longer history, optical flame detection is a relatively modern technology that only started widespread industrial use from the 1990s. The use of modern optical technology has enabled customers to benefit not only from faster response time, but in overall safety mitigation measures, especially in outdoor industrial applications where smoke and heat detection are mainly suited for indoor application. Most flame detectors identify flames by so-called optical methods like ultraviolet and infrared spectroscopy. Flame detectors are designed to detect the absorption of light at specific wavelengths, allowing them to discriminate between flames and false alarm sources. In the case of pure hydrogen combustion in the presence of oxygen, only water is produced, and this water does have an infrared spectrum signature of its own. A good flame detector must be able to detect such a signature fire that has certain behavioral patterns, such as the flickering behaviors of a flame, and have sufficient algorithms to understand that there is a real fire. FM 3260 is a global independent testing body that examines a flame detector whether it performs to its specifications in detecting various types of fire. Here you can see that the Rosemount 975HR is able to detect hydrogen fires from as far as 50 meters in a third-party test lab, and the 975UF model as far as 21 meters. The technology that goes into the design of Emerson flame detectors is incredible. The flame detector must be able to see such fires at long distances, which sometimes the human eye is not able to see. Having an external approved lab to test such performances and not just rely on theoretical paper calculations cements Emerson's top-notch product leadership in the flame detection industry. The effective detection range of flame detectors can be significantly reduced first by fewer mixtures. For example, in a real-world hazardous site, there are multiple sources of fuel that can burn. A flame detector detecting fuel that is mixed with gasoline and methane will have its detection distance less than when it's first used to detect pure gasoline. Secondly, weather conditions such as rain, fog will cause any flame detector to see less clearly, hence reducing its detection distance. Thirdly, dirty optics on the flame detector itself will also lessen the detection distance. Hence, it is important that proper maintenance is carried out regularly. To only use detection distance to gauge a flame detector performance is insufficient, as it must be used together with the field of view specification. The field of view specification is designed into 4 different flame detector models, not only to maximize its area coverage, but also to maximize its overall performance. Owing to its superior quad sense technology, the Rosemount 975 flame detector leads the market with the largest area coverage, meaning customers can use less number of flame detectors to cover a hazardous area. This value consideration can be clearly realized by customers as overall cost of ownership is substantially reduced. A high-performing flame detector must also have sufficient false alarm rejection capability. False alarms are more than a nuisance. They are both a productivity and cost issue. Furthermore, they can compromise the trust in the very system that it is protecting. It is therefore essential that flame detectors discriminate between actual flames and radiation from sunlight, lightning, arc welding, hot objects, and other non-flame sources. In the specific case of hydrogen flame, the flame detector must be able to differentiate the IR radiation produced by water from the chemical reaction of hydrogen and oxygen versus existing steam in an area of coverage. A flame detector must also be able to respond fast to a fire. Depending on a specific plant application, each of the alternative flame detection technologies recognizes a flame within a distribution of response times. As you would expect, early warning against fires and detonations is critical. Last but not the least, a flame detector must be reliable and perform under harsh conditions. Flame detectors such as the Rosebaum 975 have the Field of View Integrity Check option to warn users that the flame detector has been moved from its original position, and a built-in test capability to check window cleanliness, electronic circuit, and sensors functionality. Heated optics are also important, especially in cold temperature settings. And a high operating temperature capability is essential for certain difficult applications, such as in turbine rooms. Unlike hydrocarbon combustion, a pure hydrogen fire will only produce water. Therefore, a hydrogen flame detector must be able to capture the IR radiation emitted by water during combustion in the 2.0 micrometers to the 3.0 micrometers spectrum. But it is not so simple. The flame detector has to discriminate such IR radiation from other IR sources, example from nearby sources of steam. In a large Asian refinery, a customer has chosen to use the Rosebaum 975 HR detector as it was field proven to not succumb to false alarms caused by steam. Hydrogen fires are dangerous because it is almost invisible in broad daylight, and people could walk into a hydrogen fire unknowingly. An extended benefit of the Rosebaum 975 flame detector, which is essentially a triple IR flame detector, is that it also detects hydrocarbon fires. And this is especially practical in a hazardous installation where there are gas mixtures in the atmosphere and also other materials such as wood and paper that can combust at the same time as a hydrogen fire. You may be interested to know that Emerson also offers a UVIR flame detector, the 975 UF model, that is able to detect hydrogen as well, although its detection distance is less than half that of the 975 HR model. Where it all began. In 2015, Emerson acquired Spectronics, market leader in fire suppression in the military industry. In the same factory located in Israel, we research and design military-grade fire suppression systems that utilize the state-of-the-art flame detection technologies. You can imagine the rigorous testing and exceptionally high quality standards we have to execute in order to deliver field-proven fire suppression systems to military vehicles worldwide. Can you imagine if a flame detector in such a vehicle is not able to detect fires or constantly produce false alarms? Well, it is entirely not acceptable. In the 1990s, Spectronics brought the famous triple IR flame detection technology into the industrial market. And since then, it is widely accepted by numerous customers and adopted by other manufacturers. In our factory today, the same quality, engineering, and research standards used in the military applications and adjacently used in designing our industrial products. We ensure electronics of the highest quality and reliability in our industrial manufacturing processes to ensure best-in-class performance. In the next slide, I will introduce our next generation flame detectors, which we successfully introduced an enhanced technology called the QuadSense, which further strengthens our position as the market leader in flame detection. In our next gen flame detectors, we energize 4 IR sensors in 2 sensing channels to capture IR radiation and feed the signal into the digitizer. You are looking essentially at 2 triple IR detectors in one unit. In this age of digital transformation, we also introduce digital processing into our technology, which is far superior to analog processing and is able to generate a sampling rate of 5 times more, thereby increasing resolution by an exponent of 12. These signals are then fed into 2 inbuilt proprietary algorithms, which will process various signal-to-noise ratio to detect fires or no fires. Because of this leapfrog in technology and resolution, our next-gen flame detectors cover larger areas and detect fires faster and more reliably. The hydrogen industry is growing faster than ever before, and Emerson has been investing in technologies to help our customers transition smoothly and ensuring safety and reliability with our products. And this is what Emerson does best. Hydrogen leaks can come from different sources, such as from hydrogen fueling station, liquid hydrogen carriers, and trucks, and in gray, blue, or green hydrogen production processes. Hydrogen gas is easily combustible, and the associated flames are difficult to detect. With the QuadSense technology of the 975 flame detector, customers can be assured that the protection of their assets in all kinds of challenging outdoor conditions and the safety of their personnel are better taken care of. Thank you.